M. So we have KOH plus H3PO4 producing. So when those two collide in the right ratio and the electrons rearrange their positions, then the new substances I create are here. So the first thing I want to do is to count up each type of element I have. So on the left I've got potassium, oxygen, hydrogen, and phosphorus. Got one of these. How many total oxygen do I have on the left? 5, right. I've got 4 in the PO4 and 1 in the KOH. And on the left-hand side, I've got 4 hydrogens, 3 on the H3PO4 and 1 on the KOH. And I have 1 phosphorus atom. So on the right-hand side, I have to have all the same elements. If I somehow created a new element or didn't have one of the elements I originally had, then that's an illegal, impossible reaction. So that would be a mistake. If that happened on the exam, that would be a bad mistake. So here I have 3 potassium, 5 oxygen, 2 hydrogen, and 1 phosphorus. If you're having trouble with this part of it, you probably need more practice, just looking at formulas and counting up the formulas. Remember the subscripts. The subscript tells you how many of each element present in that combined compound that's combining elements together. So it's just a matter of counting that up. Also remember, if you had something like this, maybe I should make my writing a little clearer. That type of format, how many of element X is there? 6, right. So a subscript tells you how many of that element there are, but then if that group, in this case the X3Y group, is inside parentheses, there's a subscript outside of that that tells you how many of those groups you have. So each group has 3 X's, and I have 2 of those groups, so that's 3 times 2, or 6 total X's. So be aware of that type of formatting as well. So in this example, I have a couple things balanced, a couple things are not balanced. So I might want to start by balancing the potassium, the K. Since I have 3 on the right and only 1 on the left, I need more on the left. So I would maybe start by putting a 3 here. Every time I change it, I want to adjust all the numbers. So if I put a 3 there, that's going to change the number of potassium, the number of oxygen, and the number of hydrogen. And so now I have 3 potassium. Now that 3 I put in gives me 3 oxygen from the KOH now, because I have 3 of those KOH units. And I have 4 oxygens from the PO4, so that's a total of 7. And I have 6 hydrogens, 3 from the KOH and 3 from the H3PO4. So I've got the potassium's balanced now. What's left is to balance the oxygen and the hydrogen. So I need more oxygen and more hydrogen on the right. Right? So if I'm not sure what to do, in this case, I just look to see which side I have less on. That's the side I'm going to have to add more to get it balanced. Right, so if I already have 7 oxygen, 6 hydrogen on the left, but I have less than that, 5 and 2 on the right, I'm going to need more on the right. And I already have the potassium and the phosphorus balanced. I don't want to change that. I just want to change the hydrogen and oxygen. So I'm looking to change the number for a compound that's present on that side that only includes hydrogen and oxygen. So if it's not balanced, you want to go to the side that you have less on, increase the amount by increasing the coefficient for a substance that contains only those elements if possible. And since I only need more oxygen and more hydrogen to get it balanced, I only need to increase the amount of water. So right now, what's the assumed coefficient in front of the water? 1. So that's not enough. So maybe I don't know what to make it. Maybe mathematically I can't tell right away. So maybe I just increase it to a 2 and see what happens. How many hydrogen would that give me? That'll give me 4. And how many total oxygen would I have? 6. So I'm not quite there yet. So I would say, okay, well that's not enough. I still need more. So maybe I'll go with the 3. Now, 3 times 2 gives me 6 hydrogens. And 3 oxygens from the water plus 4 more from the K3PO4 gives me 7. So now it's balanced.